Okay, so on to question number 3. Label each proton with the predicted splitting pattern it would exhibit in a 1 NMR spectrum, either a singlet, doublet, triplet, quartet, or multiplet. They can be used once, more than once, or none. Okay, so I'll just write first one of the main rules for determining the splitting pattern. And this can be described as n plus 1. So n is the neighboring atoms containing hydrogen. Okay, so this will make more sense once we start getting into the example that is given. Okay, so let me just write this out a little more clearly. We start off with a carbon that has 2 chlorines and 1 hydrogen. We have another carbon that contains 2 hydrogens. This is bonded to an oxygen group. Another carbon with a carboxyl functionality. And then lastly, a carbon that has 3 hydrogens. Okay, so I'll just also add that when we have an H-NMR signal, there is a signal for every unique hydrogen in the compound. So that means that every signal corresponds to a hydrogen, and each signal will also split a certain way using our splitting pattern, which is n plus 1. So let's start off with the hydrogens here. So when I mentioned that each NMR signal corresponds to every unique hydrogen, this means that when your hydrogens are in the same environment, then they will only show that one signal. So an example of this would be these 3 hydrogens here, which I'll just kind of box. So this is an example of 3 hydrogens that are in the same environment. They're all bonded to a carbon that's bonded to a double bonded oxygen. So if we look at these 3 hydrogens, their neighbor is the carbon that has the double bond with oxygen. So I'm just going to write that their neighbor has no hydrogens. So if we look at our splitting pattern rule, where the neighboring atom containing hydrogen doesn't have any neighbors, it is equal to 0 plus 1. So this means that this splits as a singlet. Okay, so that is for those hydrogens. Next, let's look at the two hydrogens here. So these two hydrogens are considered identical, so they also have a signal on the HNMR spectrum. And let's look at its neighbors. Their carbon is bonded to an oxygen, and it's also bonded to a carbon that contains one hydrogen. So this neighbor contains one hydrogen. So using the splitting pattern rule, it's going to be 1 plus 1, which is equal to 2. So these split as a doublet. And then lastly, let's look at our last hydrogen, which is by itself. It is bonded to a carbon that's bonded to another carbon with two hydrogens. So the number of neighbors, well, that carbon that has two hydrogens, I don't know how to word it, but yeah, it has two hydrogens on its neighbor. So therefore the splitting pattern is 2 plus 2, or 2 plus 1, sorry, which is equal to 3. So this signal will split as a triplet. Okay, so again, like HNMR splitting patterns can be kind of like confusing if you're not used to doing this sort of work, but once you kind of break it down and try to look at each individual portion of like such a large molecule, you kind of get the hang of the different splitting patterns that that takes place in the signals. Let's see what the junior tutor said. On the rightmost part of the diagram, its neighbor doesn't have any attached protons on it, so the hydrogen atoms here can be safely defined that it has a singlet splitting pattern. On the rightmost part of the chemical structure, it has a neighbor. I think they mean the left part. It has a neighbor with two protons present. The rules for identifying its splitting pattern can be used where n plus 1. The neighbor atom has two hydrogens into it. Thus n plus 1 is equal to 3. Therefore, it has a splitting pattern of triplet. Finally, the carbon atom with the two hydrogen atoms has a neighbor, which is the rightmost, I think they again mean the leftmost element, with one attached proton into it. Using the rule, the splitting pattern can be predicted to be 1 plus 1, which is 2, which is a doublet. Yep, so I'm gonna say that this solution is correct. I'll try to fix that typo, which I... The leftmost part of the structure containing one hydrogen will split as a triplet.